We are going to talk about the question 2, week 2. Okay, so we are going to create a function which is called Hermite. Okay, I have created my own function, so I put Hermite with 2t. All right, so Hermite function t. So we need to see both of them together. Okay, so we had previously in question 1 we had t data, okay, and b as distance data and speed data. All right, so now we need them as input. Okay, so t data, distance data and speed data. Okay, let's go here. Okay, so t data is the time, y data is the information about the distance, and z data, as it's written here, z data, the information about the speed. Okay, now I get them as input, and also after creating the polynomial, for example, as in the question 1, you will be asked to say that, okay, what's the time and speed in t equal 10? Okay, t equal 10 is, let's look at this example, it's between 8 and 13. You have the information 8 and 13. Okay, so t equal 10 is between 8 and 13. So that's why we call it interpolation. Okay, so I just created this one for the Hermite polynomial, but you can create that one to obtain the speed version as well. Okay, so just the Hermite example, I just copy these things, but I don't get this. All right, I will copy this one, n equal length t data for t. So in the Hermite function, in the function version, instead of t, I will call it t data. Okay, so n is equal length of t data, not t. Okay, here n is equal t, and there is n equal length of t data. Okay, again the same thing for creating the coefficient matrix using the vectorization. Now they put those upper half, lower half of the matrix together to create the complete coefficient. All right, and b is y data and z data. Okay, let me remind you that b is this one. The first 4 is the distance information, and the rest 4 is speed information, which we call z data in the question 2. Okay, so sorry, little bit these numbers 77, 30, 54, 102, they are not compatible with this. Okay, but it should be the same. All right, so let's do, okay, here again solving the obtaining the coefficients a and this one, and I just obtained Hermite polynomial. I didn't obtain it here Hermite derivative information, but it is easy to do that. Okay, all right, so I have the function, I want to use it. Okay, in order to, okay, do you have any question? Okay, see, I just simplified it, so I can write a lot here, so it's possible to write the derivative version as well. Now I'm going to use this function. Okay, here, so I have t data, this one, 3, 5, 3, 8, 13. So but it's in a comment version. Okay, this one z data. Okay, yeah, but see this one here. If I want, I can use this data, so I need to uncomment them. But I will use this one, so I don't need to comment them. Okay, t data, y data, z data, and TV. Our TV is like here is t values. T values are the between like the interval that we want interpolate the function. All right. So t values comes from the line space between the smallest time, the minimum, the initial time, until the end of the time. Okay. So line space means the line t values between them, any time between them. So yp is the Hermite t data, y data, z data, and t values. What is Hermite? It is in MATLAB. If I create a function here, I can call that function in another editor. It's possible to bring this one in a way that in a place that I want to use, but I should end it. If I start with function, I should end it here. Okay. But traditionally, usually I separate everything. I don't write everything together. All right. So yp is the Hermite function, which is this function that we created here, and then I'm going to run and see what happens. Okay, I just created the distance function. Why I have just one output? Because I was lazy and I just created the Hermite polynomial. Maybe we can add the speed one.
Is this the end? This is like the end.
All right. Okay, this is the Hermite polynomial. In fact, okay, I think so. It won't work because if I want to create that function, it should be like I can't create like two functions. Okay, so I need to write it separately. Okay, so I just erase this one. So this function will work for me. Okay.
Can we just plot the non-derivative one?
Yeah, non-derivative one. Okay. So now it's possible if I have so we can see the with using the data type, it's possible to approximate the time, the distance of the time in time when time is the 10. Okay. But anyway, we can use the Hermite function in command window as well. Okay. Let's see what happens. Okay, I have t data here. T data. So I have this function. So what happens if I put, so t data is like, can you see? Sorry. Okay. Okay, Hermite function I created. So t data it's already saved, y data it's already saved, z data is already saved. Okay, but t values I want to choose it 10, so it will give me this function. What was this? Okay, in t equal 10. Okay, it's this one. So I can see the value of the distance on the plot, and also using my function. Okay. All right, let's do here. See, okay. The command clear will clear every data has been saved in MATLAB. Okay, so okay, CLS. Okay, T data. Okay, T data, Y data, and Z data. Okay, I have them. Okay, what's the T data? We are not sure if we did it right. Okay, it's this one, T data. Okay, what are the so Hermite? Okay, using this function. Okay, Hermite function. I created this function, Hermite. I have 4 inputs: T data, Y data, Z data. Okay, I already saved them in MATLAB. Okay, what I didn't put the saved as input is the last one. The last argument I choose it to be 10. All right, so I can obtain my function. I can obtain the distance of the car in time when time is 10. Okay, now it's possible to I can comment this. Okay, and I can start to uncomment this, and instead of that one, because I just want to practice for exam. Okay, so I can choose two different numbers: time, Y data, and Z data. It should be a little bit different, you know. Okay, you can create different things for yourself: time, Y data, Z data, and you can practice. You can create different function which is called the derivative Hermite, and instead of putting this loop, you can consider the derivative version. All right.